Hello, everyone. So today I'm going to be talking to you a little bit about software quality, refactoring, and kind of trying to avoid arguments with your coworkers. So before we start, there's a little bit of context that you should know about me, which is firstly, I work at Canonical. You may know us as the people who make Ubuntu. There I work in the office of the CTO, and one of my main duties is to do essentially Rust advocacy within the company, as in I'm the guy who goes around to various teams poking them and saying, like, have you tried using Rust? I think it could solve some of your problems here. It's quite fun. Mixed results, but well, here we are. It's an ongoing process. So we're currently moving to use more Rust because we have a bunch of older C code bases that we really don't want to be maintaining in a couple of years from now. Like, realistically, who does? We're made up of about like 1,000 engineers or so. Everyone's fully remote and basically from any time zone on Earth. And this last point, any time zone, will become significant later. So the next thing you should know about me is that I really, really like clean code. There's a certain zen to this that I find that if you look at a bit of code that is like super well put together and it's very obvious how this is meant to be used, how this is being created, it's really nice. And that's something that I always strive for in my pull request reviews. Unfortunately, this has a side effect, which is that I kind of annoy my coworkers. I am that guy who, after everyone else has approved on the PR, is still there saying, like, hey, there's a couple of things to fix here and there. Can we please just get these resolved before this merges? Yeah, so I guess sorry about that. Anyway, so before we start proper, I want to tell you a little bit of a story, which is that a little while ago, we were trying to bound the amount of time which was in use by parts of our processes. So we wanted to take a very, very lightweight approach. We didn't want to use like C groups. We didn't want to use like deadlines either, because the work that was going to be undertaken was in like a very async environment, and work starvation was very real. So the solution that we came up with was the idea that the tasks would declare the amount of time that they're going to take, and then during testing, we make sure that that time does actually match up with reality. So if we plot this on a graph, in an ideal world, it would look probably something like this, as in the amount of time that you declare that you use is above the actual amount of time that you used, so that we can then bound the declared time with like a budget at runtime, and then if we overrun that, we cut the task off and things don't overrun. That's all very nice. This would have been nice to deal with. Unfortunately, reality is a little bit different, and the data looked a little bit more like this. You'll notice that there's a lot of noise here, and that orange line of what we measure crosses over the white line of what we declare, which would then cause a test failure. But actually, it doesn't really cross over it very much, and perhaps this is spurious. If you run this test multiple times, those might disappear. So we really need a way of removing those problematic parts and essentially getting a line that we are more confident in. So we took an approach of just denoising it. We just employ a bunch of techniques from digital signal processing and get a line that we can reason about more reliably. The process of getting that line, it looks simple here, but it only took a month and a half, 2 months. And at the end of it, my coworker and I, we looked back at our code and we thought, wow, this looks like it's going to be really hard to maintain. We had to write quite a lot of very maths-heavy code. There were constants in there that only really came from papers, and we had to link to those, so that the next person coming along to read our code would then also have to understand these papers that we'd linked. And we didn't like that, because if we understood the code now, we probably wouldn't understand it in the future. So even though we'd spent 2 months on this, 1.5, 2 months, we decided to throw it out because it simply wasn't maintainable. And the reason we did this is because we were going for simplicity. So why on earth should you really care about simplicity? So if you go for simplicity in this way, you get a couple of benefits. Firstly, it's going to benefit new people. It's going to be a lot easier to onboard someone into your project if the concepts which you are using are nice and easy to explain. And that, in turn, will very much help the longevity of your project. You can have external contributors coming in, helping you out, not necessarily having to know all of the very, very specific and deep parts of your code base. They can just help you a little bit here and there, and that's just nice. And finally, simplicity also benefits you, although not necessarily the you of now, but the you in like 6 months' time, when you've forgotten all of the little decisions that you were thinking about right now, where you are essentially like a new person coming back to this code. And if you're reading something you wrote in 6 months' time and you think, oh, what was I doing here? Well, then your code isn't really so maintainable. So it's a thing that we always try to keep in mind here. So what is simple? This is quite subjective. So here are a couple of heuristics that I personally use. So firstly, I think easily described concepts are simple. I think that one's fairly self-evident. If you can't describe a concept in very, very simple terms, the next person who comes along and tries to understand this is going to have a hard time. Now, where these concepts then start to mix with one another, there should be a very, very clear flow between those concepts. There should be clear separation, and it should be obvious how these things fit together and collectively come together to create your solution, your bit of software, whatever. And finally, predictable patterns are very, very simple. If a person reading your code has come to understand a certain bit of it, and then they move over to another file and they find a different piece of code that they then had to work through manually and figure out what on earth is going on here, only to come to the conclusion that, oh, actually, this was doing basically the same thing that I already understood, but because the pattern wasn't the same, they've had to then expend all of that extra mental energy to understand what is going on. That's just a waste. We should really try to avoid that. So I think Rust has, at the moment, a little bit of a crisis of simplicity. And this is kind of understandable. In Rust, we really try to tackle very difficult problems. The problems we try to tackle, they're not easy. That's fair enough. But the unfortunate issue here is that the problems start to bleed through into the APIs that we create. So when we ask people to use our software, it no longer looks simple. And it really should. If we want to get new people along, it should look easy for them. Unfortunately, in Rust, it does not look easy. So if you cast your mind back to when you were first learning Rust, or perhaps if you were to ask a person who is just starting to learn it, what do they think of the documentation of the language? Then you'll probably get a fairly similar opinion, which is like, wow, this documentation is great. Isn't it fantastic that we have all these really simple examples? And then they look at the types involved and think, oh, what is going on here? Why are there so many like one-letter lifetimes? Why are there so many trait bounds? I don't understand. We expose a lot of this complexity, and we really shouldn't. So we should try to refactor towards code which is more maintainable. But really, what's stopping us doing this? Because let's face it, like if we could just have nice code, we would. So what's getting in the way? So really, when you're thinking about refactoring, there's a couple of questions that you're probably going to ask yourself, which is, how long will this process take? Is this going to take weeks? Is it going to take months? If it takes too long, am I going to start losing time from my short-term goals, the things that perhaps make my organization money? Am I favoring long-term benefits over those, and hence putting the short-term at risk? And it can be difficult to justify this. If you have targets you have to reach, it can be difficult to convince your boss that, hey, I need to do this thing that will benefit in like 6 months, a year's time. Please just bear with me. That isn't always an easy conversation. Secondly, you should ask, well, will it still work at the end of this? I don't know about anyone else, but I do quite a lot of projects in Rust, obviously. But when I used to do them in like Python and Go and these other less formal languages, I found that if I did a refactor, it would usually end up killing my enthusiasm for the project, because I would have something working, that's great, and then I try to fix it, and now it's just broken. And the effort of actually fixing it or bringing it back to the state where it was working again is just too much. And it's very unfortunate, but that has sadly destroyed some of my projects, which is, well, not great. And finally, if you're in an organization, you're going to need to ask the question of, will we lose people over this? If you are going to ask a person to spend 6 months of their time, a year, purely working on massaging a legacy code base into a form where it can serve another couple of years, rather than working on something nice and new and exciting and interesting, it's natural that people are going to want to move on, right? No one wants to work in a job where they don't enjoy it, really. So I think Rust kind of has a almost unique advantage over other languages when it comes to this stuff. which is that we kind of have this notion of fearless refactoring, which is a term I'm coining just now, which I'm essentially defining as after making a change, the next time that all of your checks pass, your code likely still works as intended. Now, out of the box, Rust is really good at this. Like we have the compiler, which is going to poke you and make sure that you've considered lots and lots of different things. We have the linter to make sure that your code usage is nice and idiomatic. But we can help out the compiler even more. If you program in a certain kind of way, it is possible to encourage the compiler to give you errors later that will then benefit you once you've forgotten all of the context of now. So I want to give you some tricks that we have found that really benefit in this regard. So I'm going to go through 3 of them. And it's nothing that will really change your life, but well, we'll see. So firstly, you really want to avoid unwrap. Now, this is quite unfortunate because all of the examples in the documentation, whenever there is fallibility involved, use unwrap because we don't really want to pollute our examples with lots of error handling code. So we just say, OK, there's an error here. Don't care. Now, ironically, these good examples set a really bad example for our newbies. So, well, how can we get around this? Let's say we have a collection that we're iterating over, and we're trying to find some item in that collection. The bad thing to do would be to say, oh, I'm unwrapping. But actually, it's fine because I'm using an if and I'm guarding so that actually that unwrap can never panic. Maybe that works now. That code works now, and that's fine. But in a few months' time, when someone else has come along and made a change, and perhaps they've changed that condition, it's very easy to add in a subtle path to allow a user-triggered panic to occur in production. We really, really don't want that. But there are ways around this. So firstly, you could use expect if you really want to panic. But the difference between like unwrap and expect is by forcing us to document our preconditions, it really indicates what went wrong. When someone gives you a stack trace and it says, hey, this is exactly what went wrong, that's a lot easier to go and find the bug rather than just an unwrap failed. Go figure. When it comes to the messages, it's quite important to make sure that they have a certain form. So a convention that we use is that we like to signal to the user who is at fault. Now, it should never really be possible for a user to trigger a panic. So therefore, 90% of the time, a panic is essentially an internal error, and we should flag it as such by prefixing it with internal error. This essentially means that when the user sees this, if they unfortunately do, on the command line, they will see, oh, this is an internal error. I'll file a bug and just get on with my day, rather than thinking, oh, God, what have I done wrong? Because it's not their fault. It shouldn't be. Like, a panic is essentially, it should be our problem to fix, not the user's. Obviously, panicking isn't great. So if you want to avoid this, as you really probably should, just convert to an error. Like, there's easy ways of doing this. Anyhow is fantastic for this. That's fine. But if you could also alternatively use like if let and like pattern matching. And this is really nice because, well, Rust has implicitly put the guard that we're trying to, and unwrap that we're trying to avoid in the same statement. So now, by using pattern matching, it's impossible to have a place where this isn't sum and you're using it, unlike with the code at the very top. Now, the problem with if let is that we can get very, very deep nesting if you have lots of these things all that you need to unwrap at once. So a nice little technique is to just assign out into a variable here. I realize that you can also use let else. Let else is actually something we like to avoid because that else it can often appear really, really far to the right on the line where you define it. So when someone's reading through your code, they'll see, let. OK, let equals this thing. And then they can miss out the fact that there's an extra branch here in your code really easily. So we find that putting the match keyword there, which immediately implies that there is a branch, earlier on in the line, that's quite nice. So the second technique that we found is exhaustive matching. And this one can be really quite neat. And you wouldn't necessarily use it unless you're doing this kind of defensive style of coding. So let's say you are writing a linter, and you create a structure like this, which represents one linting problem. This is an early iteration of the linter, so perhaps there's just like an ID saying like what the lint is, and then a message saying, here's what went wrong. Can we please try to do it this way? Now, if you're processing all of the files from your from your linting in like an asynchronous way, then if you're not careful, all of these lints would appear on your command line in a different order. So we really have to sort them so that you get something nice, predictable that your user can use more easily. So for that, you just implement ORD. This is nice and easy. So quite like, so it would be possible here to derive ORD, right? It seems simple, but this places an unfortunate constraint on the struct definition that now the order of the fields must match an internal detail of the implementation of ORD rather than being semantic. So we prefer actually to put the fields in the struct definition in an order which makes sense to the person reading that struct. And then if they care about how it's ordered, we have an explicit ORD afterwards. Actually, defining this ORD is really quite straightforward. You just take the fields that you care about, put them into a tuple, and compare them, and let the existing types do all of the heavy lifting for you. But let's say someone comes along and adds another field here, like the location where the lint came from. So you can like annotate a file, say. In that case, we're going to need to update the definition of ORD so that you can have all of the lints of the same file appearing like in the same place in your CLI output. At the moment, there's nothing really telling us to go fix this because, well, firstly, in order to go fix it, we had to rewrite the compare function. But we had to go and do that manually. If that ... on the screen is like several hundred lines, and the person adding that location new field is not the original person who wrote this code, it's very easy to miss out that actually you needed to update the ORD implementation in order to maintain this nice looking output. So we can avoid this by using exhaustive matching. We literally just exhaustively match one of these arguments and then do the exact same comparison as before. Because this means that when a new field comes along, we are forced to make a decision of exactly how are we going to handle it in this ordering. So let's say someone comes along and adds a new fix field saying how you can go and fix this linting problem. That probably shouldn't appear as part of the, it probably shouldn't be one of the things which is ordering this lint. So we can just explicitly ignore this, which is kind of nice. So now, every time someone comes along, we have to consider, does this matter? The compiler will force you to do your homework, basically. So the third thing is really, we really want to limit unsafety. I think this one should be fairly self-explanatory. But let's say you have a coworker who just found the maybe uninit type in the standard library. For those who don't know, this is essentially a type which represents an area of memory, as in there's here a usize, where it's not given an initial value. It's kind of like a C-style way of thinking about memory. You just get some garbage in until you write to it. This can have some really nice performance benefits. So let's say your coworker comes along and writes a function writes some code which finds a needle in a haystack. But let's say that we also have the guarantee that the needle is definitely going to be in that haystack. So they think, oh, I can use maybe uninit here rather than just an option, because that check for unwrapping the option is just something I don't really want to have to deal with. So in order to get back this index, you have to use unsafe and then assume init to actually extract the value out of the maybe uninit into something that can be used safely. And then just for good measure, you add in one of these comments just to say what you're expecting here. This is not maintainable code. Like, it's having to look manually through all of these comments to figure out have I broken the invariance is a really cumbersome task, and it's not really possible for tooling to help you out here. I mean, sure, it can help you a little bit, but if you have like thousands of these unsafe blocks in your code, that can get really, really difficult and get very, very costly. So you should also be thinking whenever you're using the unsafe keyword, it's kind of like a note to the compiler to say, hey, hold my beer. I'm about to do something really crazy. It'll either be amazing or I'm going to break everything. Trust me. But the compiler isn't the only one that you're having to ask to trust you at that point. You're also having to ask your users to trust that you know exactly what you're doing, you know the implication of all of the changes that you're making, and that you will never make a mistake. We can't really afford to break the trust of our users, so really we should be avoiding unsafety at all. If you are thinking of using this, my question is, if you're doing it for speed, show me the benchmark. Prove to me that you need this because Rust is already a really, really fast language, you can probably get away with just having this tiny little bit of extra overhead. Sure, it's not zero cost, but it's right next to zero, so it really doesn't matter. In this case, you just use iterators and some existing methods that Rust would provide. And you may notice that those 3 lines at the bottom are far more ergonomic. It's almost like the designers of the language are trying to point you in the right direction here. Funny that. So the last technique we found is less of one which the compiler is going to help you out with, but one that you're going to be helping out your fellow humans with, which is naming. We spend a huge amount of time on naming in our team. So let's say we have a function called doTasks. It takes a bunch of things which you're going to do. It returns a vector of those completed tasks. It creates a mutable vector, a list of the things that are done. You'll iterate over each task in the things to do, and then you'll finally return this at the end. This is kind of messy. We're using lots of different terms to refer to the same things. It's not, even though you can figure out what's going on, it takes your brain a moment. Let's say we rewrite this, really trying to get the naming absolutely perfect. So the name of the function is fine, but instead of taking things to do, doTasks can just take some tasks. And we return the same type because that's already very nice and descriptive. Then we can construct a list of completed tasks, reusing the exact same terminology from the type, because that's just some vocabulary that the person reading this will already be aware of. We then iterate over task in tasks, very obvious how these fit together, and finally return the completed tasks. I would argue that that second piece of code is much cleaner to read than the first. And although the effect is quite small, over the course of a very large code base, these little problems can just add up. So we have kind of a mantra in our team, which is that, what makes a good name? So a good name is very, very concise, as in it comprises of the smallest number of words to say exactly what the thing it's describing is, whilst also implying how it should be used. It's not just enough to say, this is thing. It should be obvious to the person using this how that thing should be used, how it fits together into the rest of the solution. Now, being concise doesn't necessarily mean the fewest characters. Using non-standard abbreviations and acronyms is a fantastic way of confusing people and making your code utterly impenetrable to them, so that should also be avoided. Naming should also be very, very consistent. If you have a particular style of naming, stick to it. If you have, say, variables of the form adjective, noun, and then you add a new one, noun, adjective, that will immediately look out of place. Just make it all line up. I promise you that if you do this, it will just feel nice. And finally, naming should be correct. Like, if we give the wrong name to something, someone is going to have the wrong idea about it, and they're going to have this incorrect preconception is going to govern how they understand the code until they then read further and understand that, oh, right, I didn't understand something further on up, and it's not a very pleasant experience. We should be very careful about how our names are perceived. So the mantra we have is that good logic and APIs with bad naming are completely indistinguishable from bad logic. And conversely, if you have a piece of logic where it's not possible to assign a good, clean naming structure to it, then that is bad logic, and it's time for a refactor. So how can we avoid causing arguments about all of this? Because this all seems like really, really arbitrary, right? If we're not careful, we will end up with some really, really nasty arguments with our coworkers, because you're telling them, hey, can you fix the naming here? And they're thinking, shut up, I've got all these massive problems to deal with. So obviously we want to avoid arguments, but we don't want to completely avoid debate here. So the difference I would draw here is that an argument is something where passions are the driving factor, and the sides are unwilling to come to a collective resolution. Whereas in a debate, things are more rational. The sides will put forward their arguments, and together you'll come to something that maybe not everyone agrees with, but it will be better than the collective sum of what went into that debate. So how can we create an environment where we try to foster debate rather than just argument? So these are some things which we found worked in our company. So being 1,000 people and all globally distributed, it's not necessarily possible to reach everyone. So the first thing we tried was to set up a cross-team code review. As in, we have people from different teams within the company come and review each other's code, and together we will build up a shared sense of what our canonical version of Rust looks like. This was really fun initially, but we found that there were a lot of repeated arguments, and it's not necessarily possible to expect like a couple of hundred people to constantly be giving some of their time to this repetitive task of, hey, have you considered naming it this way? And then next week, hey, have you considered doing the exact same thing again to a different person? That's just quite taxing for all involved. So instead, we moved on to, while keeping around the cross-team code review, we moved on to a process of, well, we'll do this in a more social kind of way. The aspect of creating a community was really nice, so let's keep that. We set up weekly office hours internally that I run, where it's primarily a social event. I mean, people do come along quite often with their problems that they've had with Rust, things that they perhaps don't understand, things in like personal projects or work things that they thought should work in a particular way but actually don't. And we have a nice discussion about this, and that's all very nice. But it's not purely just for work. It is also like a social event because, I mean, we're all humans, right? The bonds that we create in these interactions are a little bit more important than just this one bit of code that we make. So fostering a community is essential in avoiding these nasty arguments. But having office hours that some people can get to is not really sufficient when, let's say, the person running these office hours is in the UK and wants to talk to someone who's in New Zealand, like 12 hours away. That's going to be unpleasant for one or both people involved, having to get up at some horrendous hour in the night. So that's not really possible long term. This is supposed to be like a 9 till 5, and I prefer to keep it that way, please. So we needed something with a little bit more global reach. So that's where we came across the idea of standardization documents, as in we'll try to collate together all of our shared knowledge of how we want to work in a particular language, Rust, Go, Python, into one place. That means that when it comes to pull request reviews, we can just say, hey, we've already made a decision about how to do this, this thing. We have it here in the standardization documents. Can we just please migrate over to this way of doing things? And that's all very well and good, but if we were to just tell people, hey, do it like this, you're going to get a negative reaction because people have usually some fairly strong opinions about how they like doing certain things. And if you can't convince someone, but you tell them to do it anyway, they're just going to harbor some resentment, and that's just not going to be pleasant. So the key thing here is to argue, but in a very positive way, as in you have a particular way that you want to do something. So you will argue that, or you will put forward an argument to say that this is the way that we want to do it because of these benefits. So these standardization documents can get quite long. This is just an excerpt of the table of contents of ours. It's not all of it. There's more of this. The actual things that are written here aren't too important for the sake of this talk, but there are a lot. How you write the individual sections is an interesting one. So you probably want to make sure that you have some explanation about how the code should look, and also making sure to describe the benefits, while also showing some nice visual examples so that someone can quickly look at this, see what we should be doing, and then optionally, if it makes sense in that section, hey, this is what we're trying to avoid here. And in that way, we can kind of make the lives of the people reading this a little bit more pleasant. So how do you go about creating one of these standardization documents? I mean, there's lots of ways, but this is what worked for us. Firstly, we make note of the repeated arguments which we're having with various different people and try to come to an idea of how we're going to resolve all of these in one unified way. You then write up the generally applicable notes here, because not all of those arguments are really going to be valid for everyone everywhere within your organization, this is. So you then you write those up, providing good arguments about good reasoning rather, about why the decisions that have been made have been made. writing this as just one person is a really good way of creating like an idiosyncratic standard which only really applies to you and which doesn't actually necessarily benefit other people. So really, you want to start reviewing this. Initially, just with like a small number of very experienced Rustaceans, so that you can get their really good advice, things that you hadn't thought of, ideas that you hadn't come across that just collectively come together and make something really nice. Then we can open this up to a wider number of people who are also experts in the language, and also some people who are just starting out, so that we can then sort of learn together. The key here is as these points go on, the document is we're getting more and more confident that the content in the document is correct and that it isn't really going to change too much. Because as we also widen the number of people who are able to be accessed in these reviews, it becomes more difficult to have the long conversations with them. Recall that someone might be 12 hours away. There's only a certain number of conversations that you can really have before one of you's got to go to bed and shut off for the day. So by the time that it gets to that person, the document should be in a good state, which is as agreed upon by as many people as possible, so that hopefully there aren't too many things that a person on the other side of the planet is going to have to nitpick about. It's not perfect, but it's the approach we took. And finally, you then release this to everyone else in the company, making sure that everyone is aware of this. And before making too many contributions, they at least have like a notional understanding and have skimmed through it at least. So this is all very nice, but this is the process on hard mode. And I appreciate that not every organization is in a place where it can dedicate quite a lot of time from quite a lot of its engineers for a process which only really benefits you fairly far into the future. So we kind of made the easy mode of this process, which is you can just use ours. It's fine. It's all open source. We did the work for you. Just go play, have fun. There's an RFC process if you want to like disagree with any of the points that we've made here. If you find yourself agreeing with some of them, but disagreeing with so many others that it's probably going to be completely irreconcilable to merge the two ideas of how Rust should look like, just fork it. That's fine. Just use your own. Make your own out of this. All I really care about is that the arguments that we're having actually matter. This is a giant list of things that we shouldn't be having disagreements about, basically. So how can we? These lists aren't perfect. They're quite long. This is an issue put by my boss that states that people aren't so great at keeping lists in their own minds, right? So we are going to end up in a situation where people are going to have disagreements, and we've already come to a conclusion about how we should do this, but they've just kind of forgotten, or they haven't read all the way to the end of the document because it's just a massive document. That's not great. So how can we avoid this? Or first of all, I should say, why should we avoid this? Because really, when we're working in these collective environments, you should always be aware that your coworkers have a kind of social battery. There's only a certain number of really hard arguments you can have with your coworkers before you're going to be going home at the end of the day thinking, oh, that was exhausting. I hope every day isn't like this. And then they come back the next day and, oh, there's more arguments to be had. You're not going to make many friends that way. So really, the arguments that we have must be focused in just the right place, as in we shouldn't be spending too much energy on things which really, we have more important problems to deal with, which is kind of the purpose of these documents. So to make it even nicer, we should think about some sort of automatic enforcement. So just taking a step back, in order to keep our code good, we already have some existing techniques, which is, if you want pretty code, use cargo format. If you want idiomatic code, use cargo copy. These are both fantastic tools. If you want conformant code, which matches up with your standards, use humans. I don't really want to do that. That's the kind of thing that we're fully trying to avoid here, just people posting things on pull requests and having to remember absolutely everything. Instead, the approach that I took was just to write a custom linter. Unfortunately, I can't yet share the code with you properly because it relies on a couple of details that we still need to iron out. But the linting rules will appear in that repository that I linked earlier. So what does writing one of these linters look like, and how can you go about and do it yourself if you like? So there are a couple of different technologies you can use. Sure, you can just like grep through your code base, but really, code has a very specific structure, and if it isn't formatted in a very particular way, it can be very difficult to write a regular expression which handles every last case. So really, the approach that I used was to use treesitter, which, if you're not aware, is a fantastic library used by most modern editors now. I think like NeoVim has it, Zed has it, I think Helix has it, maybe a couple of others I'm forgetting. It's basically like a general way of parsing programming languages and being able to reason about those in a single, like a single environment. I'll show you what this means in a moment. So once you've parsed your source files, then treesitter might consider it to be something like this string representation of it. So in this case here, we just have an expression, like one line of code, which consists of a call, and the parameters to that call is just one string. There's a bunch of other tokens here that we don't really need to care about, like brackets and quote marks and stuff, but there you go. Now, in order to find these problems and parts of your code that don't conform to your standard, you really want to perform some query against this. And handily enough, treesitter has the ability to perform queries written in roughly the same form as the syntax tree that they emit here. So if you want to match this call expression here with a particular function, let's say you're looking for panic functions. This is one that we use for Go. And you want to extract the message which is outputted from, which that panic will then use, then you can use this query. It's very similar to the previous one. And treesitter will give you a list of nodes which match these parts that you have extracted here, and you can then do some reasoning about it. And then finally, when outputting from these linters, it's always nice to have some helpful output. I used snippets RS, which is it's a really cool crate. I think originally it came from it was like copy and pasted out of the Rust compiler, because well, the Rust compiler has these pretty amazing error messages, and other people want to use them, and that's basically what the snippets RS library does. So using that, we can provide information about what went wrong, and provide some information of how you can go about doing it in a better, more standard way. Because we are trying to create like a very constructive environment here, so providing advice right where the user is about to act upon it, and also providing the reasoning, just briefly, can be quite nice. So the big question, has this resulted in fewer arguments? That's quite a difficult one, really. But what I can say is that it's definitely resulted in fewer debates. In better debates, I should say. Oops. Yeah, so I think this has definitely been a worthwhile exercise. That's that. Questions?
Okay. Are there any questions? Okay. Can you pass it on?
So I'm gonna drop the AI bomb. Using an LLM to, trained on somehow on the guidelines and.
I mean, that is a possibility, but the question is, do you trust AI? Like, an AI is essentially trying to imitate human behavior. It's not actually that intelligent at the moment. Like, ChatGPT is literally just a text engine. If you ask it a question, it will tell you what it thinks it's correct, but if it doesn't know the correct answer, it will still give you an answer. So the problem that I have is that if I were to use an AI in its current state on this, you may end up with like lots of false positives and things which aren't caught. And for the moment, at least, I prefer a more deterministic approach that we can be very, very predictable about. I don't know if that will change in the future. I mean, AI it seems to be going at like a crazy rate right now. So maybe in a couple of years' time, all of this stuff will be obsolete, and we will just be like chucking a language model at our code. But for now, so long as an AI is trying to imitate a human, they're still going to have human-like defects. And if we still have human-like defects in our CI, we haven't really solved the initial problem, which is that humans forget things. That's just my feeling, at least.
It's a cheaper human.
Well, is it cheaper? That's the question, because they are also super expensive to run. So if you have a CI pipeline that's taking like minutes or hours every time that you're running this, I mean, the planet probably isn't going to look very happy about that. No.
Thank you.
But it's a fair point, though.
A small technical implementation question. You mentioned that you're using tree-sitter for the parsing and the tree matching. I don't remember the name of the project. I know there is the possibility to define dynamically loadable Clippy lint rules with the same engine as Clippy, which means scene, essentially. So there are. Did you consider that? Yes, no, why?
See, that is an interesting question, because we already have the fantastic tooling of Rust that we can use to improve our Rust code, right? The reason why I took a tree-sitter approach for this project was because Rust is not the only language that we're using at my company. So we strongly associate ourselves with Python, Go, C for the moment, a little bit of C++ here and there, but we're trying to get rid of all that, and now Rust. So I really wanted a tool which would be applicable in all of these environments. And as fantastic as making extensions for Clippy would be, I didn't really want to have to replicate my effort across all of these languages manually, essentially.
Thanks.
Any other question? Okay.
So what I was wondering is, like, do you have any recommendations for like introducing this kind of automated enforcement of these rules to like maybe an old code base where there's probably a lot of existing violations, but you maybe don't want to have to fix all of these, but you still want the automation to, like, you know, enforce it for the new things you add? Is there any way you can really do this?
That is a tough one. In the linter that I'm writing at the moment, so a feature that I'm currently working on is the idea of being able to group lints together and being able to deactivate them. So the deactivation of lints is something that it's currently it's sitting in a pull request. I think it's nearly ready. But a thing that you could do is chuck this linter at your old code base, but turn off all of the lints initially, and then manually go through and turn them on one by one, just so you don't end up with like thousands of problems to deal with all at the same time, because that's going to be a really miserable couple of weeks working on that. So yeah, I think my advice is just take it slowly. You will get there, and once you get to a position where you have managed to remove all, or at least most of these problems, perhaps you've put ignore markers, like this is okay just here. Once you get to that point, it will be so much easier to work with the code base that you'll no longer be thinking about the linter. Yeah, legacy code is it's a real problem.
All right, thanks.
Yeah, thanks. Regarding the exhaustive matching, I like the idea, but how do you handle then? I mean, would you use that everywhere, or just in places where you expect things to change? How do you deal with nested structures and?
So the key to this is it's really moderation. So the techniques which I showed are quite. Get the link up there. The techniques I showed are really quite heavy sometimes. Like the exhaustive matching, you saw that added quite a lot of lines to what was an otherwise very simple function. My advice is really don't apply this religiously. Just apply it where it makes sense. Because there will be some places in your code base where you don't need to definitely consider every last part of some structure. In those cases, don't do this. Like you're just going to. As I mentioned, like the sort of social battery, there is also a frustration amount that gets deducted from that every time someone gets an error. So if you're providing enough errors that it's helpful, that's great. If you're providing so many errors that it's overwhelming, that's less fun. So yeah, moderation is key, I think.
What's the release schedule for the linter look like?
I'd probably give it a couple of months, like within 6 months. It's essentially, there's a couple of things that we need to nail down and then port out of other projects into this before it's in a state where I'd be happy to say, hey, I wrote this, it's got my name on it, it works. Because at the moment, things are a tiny little bit unstable, and if I release to too many people right now, bang, it's going to start breaking people's stuff. So I'd say probably latest, probably sometime in the spring. But it will appear in this repo.
Got it. Thank you.
Amazing talk. My question is, do you already run that tool in CI? And if so, do you block the build on code violations?
That's a fun one. So if you don't block the build on these code violations, they will build up. Because if you have warnings in CI, are you really looking at these warnings? You've got other things to do. You look at errors. So as pedantic as it might seem, I'm already in a position where I am blocking people's PRs on account of pedantic things. So this tool for me is essentially just me, but in the command line, or me in your CI saying, hey, no, go fix this. So yes, I do block on code quality, because if we don't, it will slip. And then we just end up in a situation where we're essentially creating more legacy code. So I really don't want that, hence I say no.
Thanks.
Thanks.